Welcome to the solution video for the API to-do list challenge. Let's go ahead and get started in Visual Studio. We're going to start by creating a new project, and it will accept the terms. And once we do, we can come back over here. And here's a new feature that's really quite nice. In our refactorings, where it says there's red squiggly, I can come down here and say add missing usings. Notice there's two different using statements that are missing for this particular class file since I pasted it in. If I select add missing usings instead of just adding the one using, it will add both of them that I need, and it takes care of all of my red squigglies. Okay, so this class, what it does is we initialize it with a database name, and that creates a connection to the database. And then we can insert records, we can load records, we can load record by ID, we can upsert, which is either an insert or an update, depending on if it finds the record already existing in the MongoDB database. And also we can delete records. So it's basically a simple CRUD class. I am going to add this to my source control, or not my source control, into my dependency injection system. So let's create an interface for this. Just the basic stuff. Now note that the constructor takes in a string. So that's going to be a little bit of an addition that we have to think through. How are we going to add something to the dependency injection system that takes in a string? Now I'm going to do that the simple way. There are more complex ways of doing this, but if we go to the startup class and come down here to our configure services, this will be a service we want to add. So we're going to say services.addTransient, and it's going to type iMongoCrud. We're going to add that, but we're going to say X arrow function, or the lambda expression, new Mongo CRUD with the database name of to-do. Now I'm going to actually make this into a static constant we can access anywhere. So let's create a class for this, and we'll discuss what we're doing here. So this is going to be the application setup or config application settings. Okay, let's call it that. Public static class, and we'll make it a public static, a public constant. And this is going to be called Mongo. String. There we go. We're going to call it MongoDB equals, and we'll say to do. And then you can come back over here. We can pass that in. So application settings.mongodb. And that will pass in that name. And then we have one place to change that, and that's in the constants. Could we go even deeper than this and pull it from a configuration file or somewhere else? Yeah, probably. But I think this is good enough for our application. Now we also want to have a table in here. So we'll create that now. Public const string Mongo to do table. To do list is what we're going to call it. And now we can access that as well. Okay, so now that we have manually so we can pass in parameters to our database instance, or to our class instance about the database, sorry. So that's what's going to handle the setup for us. So now we can just ask for an iMongo CRUD and get the right value. So that's a little bit of setup work. Now let's go to our controllers and let's add a new controller. This is going to be an API controller. It's going to be empty. We're going to call it to do. Once that gets created, then what we'll do is we'll kind of scaffold out our different methods that we needed to handle. Okay, we also need a model. So let's right click and add a folder called models. And we're going to create a model in here for our to-do item. To-do, let's call it to-do model. And we need a couple of values in here. We need a GUID, and that's going to be our ID. We're going to need a string, which is our to-do text. And we're going to need our Boolean for is complete. And we'll leave it at that. Now I do need to say that this is a bson ID. Oops, that's kind of, there we go. Which control dot to add our using statement for mongodb.bson.serialization.attributes. What this does, it just tells MongoDB that this is the unique identifier for the record. So now that we have that, we can create our scaffold. Let's start with the most obvious one, which is the get the whole list of to-dos. So public, let's make an I enumerable of type to-do model. We'll add the using statement for that. So I enumerable of type to-do model, and this is going to be our get call. And we're going to make sure that this is an HTTP get. Be very clear about what that is. And then we're going to have another one that's an HTTP get. But this one is going to be a just get one of them. So we're going to have a special route here, and that route is going to take in an ID, like so. And now we can say public to-do model get one. And we need to pass in an ID here, so we need to pass in a GUID called ID. So it's going to get just one based upon its ID. And then we need something to create records. So that'd be a post. Oops, not patch. It's post. There we go. And it's public. Let's do void for now. And this is going to be post and to do model to do. And let's just put a comment after here that this is the create to do. We could call this create to do instead of post. I'm matching it up with a verb. It's up to you how you want to do this. Now let's create our update statement, which is a put. So public void put. And we're going to pass in that same to do model to do. And we'll put after here that this is the update a to do item. Next, we want a patch. So HTTP patch. And this is going to be our marking it complete. So public void patch. And we're going to pass in a to-do model. But one of the things about patching is you don't have to pass in all the parameters. That's kind of the thing. So this is where we're going to mark complete. And so we'll figure out how to just accept the values we need to. Now again, we could call this something a little more clear to indicate that this is just marking it complete, not doing anything else. But I think that's good enough for our demo purposes. We also need a delete. And this is going to pass in, we're going to pass in a full model here. I'm going to show you why in a minute. We could pass in just the GUID, but doing so causes some issues on the route. It makes it a little more difficult to deserialize that GUID back into a GUID. So instead we'll pass in the whole model, but just look at the GUID itself. So now we have our verbs. We have two gets. We have a post, which is to create the record. We have our put, which is to update the record. We have our patch, which is to mark an item complete. We have our delete. So that should take care of everything that the challenge specified. So now let's get to work filling these in. The first thing we need is to have a constructor here. And this constructor needs to ask for an I Mongo CRUD. And let's just call it DB. We'll do a control dot here and create and initialize the field, the second one. And so it now creates and initialize the field. I have tweaked my settings slightly so that this private read-only field, it creates an underscore in front of it saying that this is a read-only item that came from the constructor. So that's a slight tweak in my Visual Studio, but the control dot should create something similar for you. If not, you can type it out as well. So now that we have this, we can start working through our various items. So let's start with our get. We're going to return underscore DB dot load records. Mongo to do table, and the GUID is going to be ID. That was what was passed in on our route. It's pretty easy to pass it in on the route itself, on the URL. It's a little harder to pass it in through a post or a delete. That's why down here in delete, we're passing the whole object. Okay, so next is post. So db.insertRecord of, well, you don't have to pass a type in. You can say application settings.mongo to do table, and the record is to do. And from that, it infers what the type is for insert record. Now for our put, underscore db.upsertRecord, and that's going to be of type to do model. And upsert takes in application settings.table, then a GUID, and that will be to do.id, and then finally it takes in the actual item. So I didn't really need to pass in this type. I can get rid of that, because it infers it from this last type down here. The reason it's passing in the ID, even though it also takes in the whole item which has the ID, is that it doesn't necessarily know this type T has an ID field to pull from. Therefore, you pass it in separately so it can do a lookup on that ID and then do our upsert. Again, .id. Okay, so it's going to look up what the record is currently in the database. Now what we're going to do is we're going to say original dot is complete equals to do dot is complete. So you're going to overwrite the original's is complete value with the one they're passing in. Now we'll do a db.upsert, and we'll pass in first of all a table name, and then the GUID. Actually, we can do original now, .id. And then the record itself, which is original, not the to do. Because we're only passing in the changes for the is complete. Okay, so that's the patch. And then delete is fairly simple. db.delete record of type to do model, where we're passing in the table name and the to do.id, the GUID. That's it. So once you have this code right here, the Mongo CRUD, which you can download, but it's essentially this stuff doesn't really need to change at all. That can just kind of sit there as it is, and maybe at some point I'll put this into a NuGet package, because it's just it makes it simple. We don't have to think about how these things work. We just ask for what we need. So once you have that, it's just a matter of calling the right method and passing in the type. That's pretty much all you have to do. And now we have our full API. Now, if we start this, it's going to start on Weather Forecast Controller, which I don't like. So let's go to Properties on our project. If we come down to Debug, it says Launch Browser, and it says Weather Forecast. I want to say To Do instead. And that's for IS Express. I'll do the same thing for API To Do, so that both of them have that same value. of items. Let's actually zoom in a little bit here so you can see a little bit bigger view. It's not great, but it's better. Okay, so now we have that get call, but let's start doing some other calls. So let's start with a create call because that seems like it's one that we need. So we can put a record in here. So I'll go into a post. That's going to be our create. And we need to pass in some values. So let's go to the body of the method, click on raw, and then change from text to JSON. We're going to pass in one record here. So we have our to do text, and that's going to be a value of, let's go with take out the trash. And then we have our is complete, which is a value of false to start with. I don't technically even need to pass in is complete because that would default to false, but let's pass in those two values. Let's run this, and it says right down here that we have a status of 200 for success. Let's come over here, we'll paste in that same call. This is a get. Let's run it again, and now we can see that we have one record, take out the trash, that's not complete in our list. So let's pass in a couple more. Let's pass in another one. We'll just change this message from take out the trash to clean up my office. And hit send. We got 200. And one more, wash the car. We'll hit send. Now we call our get command. We now have 3 records. One is take out the trash, one is clean up my office, and one is wash the car. Notice that the GUIDs are different and they're populated because I didn't pass anything in, but our insert creates a new GUID each time when we insert a new record. So it's going to generate a new GUID for each of our inserts. Now let's work on the various other commands that we have. So let's update a record. So we're going to have a put. We'll pass in that same URL. We'll go to our body. We're going to raw, change it to JSON. And the put is going to update an existing record. So let's just copy this command, or actually let's go over here and copy this one. Okay, this is an existing record. And the idea here is we're going to update this record. There we go. So this record, that is the correct GUID for it. So that'd be, we already know what the record is. We're going to modify an existing one. And it says take out the trash. Let's say take out the kitchen trash instead. That's going to modify this record. Now we need to pass in all the data. Otherwise, it will overwrite the data with default values. So we pass in all the records for a put, or all the values. So we hit send. We get a 200 message saying that it was successful. Now if we run our get again, it now says take out the kitchen trash. So our put works. Now let's do our patch. And patch is right here. And I'm going to paste in that value, which is actually 2 copy and pastes ago. So I'm going to do my Windows clipboard ring, which is the Windows V command. I'm going to paste in that. And then I'm going to go to body, go to raw, change it to JSON. I'm going to paste in the ID for this entire record. But instead of passing in everything, I'm just going to pass in the GUID, and I'm going to change is complete to true. Let's run this patch command. And it gives me a 200 success. Now I can come back over to my Git and call for this. And now notice that it still says take out the kitchen trash, but the is complete is marked as true. So we know patch works. Now let's move on to the delete. So we're going to delete, let's just delete the same record. So I'm going to do a delete command. I'm going to paste in the URL. I'm going to body, raw, change it to JSON, paste in that whole object, but this time I'm just going to pass in the ID. That's it. We don't need any of the other values for our delete command. So we're passing in just the ID. We hit send. We get a 200 success. So we go to our get command and call it again, and this time we only have 2 records. That take out the kitchen trash is no longer even there. So we marked it complete and we delete it, 2 separate steps. So now the last thing to test is getting just one of these values. So let's take this one right here, which I copied the whole thing. I'm going to say to do / and paste in that GUID. And hit send, and now it gets just that one record. So with that, we've tested all of our endpoints on our API, and they all work. We're saving it to a database, we're loading from the database, we are inserting, updating, deleting, modifying, marking it complete, everything we need to do for the challenge. Okay, so that is the primary challenge. Now let's move on to the bonus challenge. And the bonus challenge is all about adding a Swagger display for our API. So we can see this documented a whole lot nicer. So to do that, we need to add a few NuGet packages. So manage NuGet packages. And we're going to search for Swashbuckle. And Swashbuckle is a Swagger UI system. So we need to have swashbuckle.aspnetcore.swagger. That's one of them. We'll install that. And I am installing the latest release candidate version of this because of the fact that I'm using .NET Core 3 and .NET Core is not quite out yet. We also need ASP.NET Core Swagger Gen. So swashbuckle.ASP.NET Core Swagger Gen. We'll install that. And the final one we need is swashbuckle.ASP.NET Core.Swagger UI. We'll install that one as well. So there's 3 different pieces to install here. Make sure you get all of them, these 3 right here. If you're not seeing the same results that I do, make sure that you've checked that these packages are the packages that you're using. I'm using the version 5.0.0- release candidate 2. Okay, so now that we have that, let's modify our startup.cs. And to do this simply, there's not a lot we need to do. One of the things we need to do is up here in our configure services in startup UI or startup.cs, we need to add a service. So services dot add swagger gen. And it's going to be we're going to create a Lambda expression here. So the arrow function, we're going to have our curly braces. And then inside here, we're going to have x.swaggerdoc. And we're going to need, I'm having some problems with my tongue today. We're going to need to specify a version here. So it's going to be version 1 of our API. We're going to say new open API info. We're going to do a control dot here to add the using statement for Microsoft.openapi.models. OpenAPI is the next generation of Swagger. So Swagger was something they gave to the OpenAPI project, and now the next version of Swagger essentially is OpenAPI. And so you'll hear those names interchangeably, and in fact, the more correct name is OpenAPI, but everyone knows Swagger. So that's why the mixing of the two. Let's do a little bit of configuration here, not much. Let's just set the title here. Let's call this the to-do API. and we're going to set the version number here to be v1. We'll press semicolon at the end. You can do more configuration here. So if you look at the description, the extensions, the licensing, terms of service, all that kind of stuff, you can modify that if you want to. But I'm going pretty simple here with just the basics. Now we've got this service configured when you come down to our configure method. Inside here, we're going to do it right after the if statement. I'm going to say app.useSwagger. So that's the first part. Your docs for those different versions. For us, we're just going to do one version. It's version 1, and this is the file will auto-generate with all the settings for Swagger, and then this is the name we're going to give the user interface for this version, which is To-Do API version 1. With that, we should be all done. Let's run this. It kind of seems too simple, but it really is impressive what it does. Now, this by default, what it's done, let's zoom back out here so we have it. This is run the get command. So we have the 2 records we actually have. But if I do, instead of /to-do, I do /swagger. There's our Swagger UI. It's version 1. And we can see that we have not only our to-do list with get, post, put, patch, delete, and a get individual, we also have our weather forecast, which is that default model that we don't really use. We should have deleted it, but it's there still. So it also has our schemas. So the to-do model looks like this. It's a ID, a to-do text, and is complete. And that would be a string or really a GUID, but that's what it's specifying in parens, a string and a Boolean. So we can do our get here, say try it out, and execute. And notice it returns back 2 values, our 2 records. We can grab the second record, wash the car, and copy that GUID. I'll collapse this, go back to this one, and for this I'm going to try it out and pass in the ID, that GUID ID, and execute, and now we get 1 record back, the wash the car record. Now let's do our put here. We're going to try it out. And in here, we're going to edit the body. So we're going to change this GUID, which it generated by default. We'll paste in our own. And we're going to say it's false, not complete. And the value is, instead of wash the car, we're going to say wash the SUV. That's a little more precise. Wash the SUV. We hit execute, and we get our response code of 200, which we can now come back to our get, and we can execute this again, and now we have wash the SUV. Let's zoom in a little bit. We have wash the SUV instead of wash the car. So this user interface now works with Swagger. We've got all the endpoints listed here, so we can see how to make calls to our code, and we can even see we have one too many, and that's the weather forecast. So let's go ahead and delete that while we're thinking about it. So weather forecast controller, we can just hit delete on this and get rid of it, and also the weather forecast model. I don't think we need either. And it should be that we can just run this and it won't be a problem. So if we do /swagger, now it just has, oh, it does have the weather forecast still. So we'll need to do a clean solution and rebuild. And that should solve the problem. Let's run it again. We can also set the swagger to be the thing that starts up instead of to do. There we go. So a rebuild cleaned out the bin folder where the that JSON file was. So that took care of cleaning up this Swagger document. We could start on Swagger though, which seems like a better place to start than starting on to do. So let's do that. Let's go to our properties. And our debug, we're going to change it to Swagger. And I'll do the same thing for both IIS Express and the API to do, which API to do is that self-hosted model. So now if we run this, it should be the page that launches is the Swagger doc. And that seems like it's the best option for kind of the web UI for an API. It doesn't make sense to have a get command that's showing JSON data on a page that's just kind of ugly. This seems to work out better. Okay, so with that, we've completed the bonus challenge as well. So in a lot of ways, the bonus challenge was a little easier than the primary challenge. It was just hook up those couple of things and we're good to go. There wasn't really any big challenges in this challenge, but there's a lot of little nuances that you might not have known or you might have gotten stuck on. And that's one of the reasons why we do these challenges, is because it may seem like, oh, that's an easy challenge to do until you hit those little nuances, those little things that, you know, how do I do this? Like, how do I do a patch command so that I don't update everything just that one value? Those type of things are important to figure out, and those little nuances help you become a better developer. You're more rounded when you add more and more of those to your toolbox. You've seen those before, you know how to conquer that particular challenge. Okay? Thanks for watching, and as always, I am Tim Corey.